Well, we had some problems with the last video, so we're going to continue on here, do somewhat of a protracted section. If you listen to the other presentation, you can see where we were in the slides. Well, we had finished talking that our ownership costs would fall over the longer period of time that we use the vehicle, but our operating costs will generally increase with the required maintenance. And so we need to find a place where we get a decent balance from this process. So let's consider what our ownership costs are. The first is there's a depreciation, the loss in value. The vehicle decreases in value with time. You know the purchase price. To estimate the ownership period, how many hours you're going to use it, estimate the salvage value, we can sort out what that ownership period is. In terms of interest, we have to look at the financial burden. We want to grow our capital. Taxes, we may have some personal property taxes, local. In terms of insurance, we certainly want to mitigate risks. Storage, which may even just be a fence or a yard where the vehicle is parked when it's not on a construction site, needs some protection, and then licensing fees may be required by the local jurisdiction. Again, all of these costs will fall as cost per hour the more we intend to use the vehicle, predominantly because the vehicle will depreciate. So let's take a look. Let's do an example. We have a contractor who's purchased a track dozer for $155,000, estimates his annual usage about 2,000 hours per year. Salvage value at the end of the tractor's life is going to be about 12% of the purchase price. Contractor estimates his ownership factor at 9%. The partners have decided that that's the rate of return that they want. And then we don't need any licensing. The tractor's not going to operate on the highway. So we ask a question of ourselves, what is the estimated annual ownership cost of the dozer operated under average conditions? So let's start where we start to look up some data. This is an industry publication that gives us an idea of how long pieces of equipment will last depending on the intensity of their use. Favorable conditions would be, you don't really have to go up or down hills, you're always on paved surfaces. Unfavorable, you're rolling across rocks or broken terrain all the time. We went with average conditions, and an industry resource could be a Caterpillar, could be Komatsu, could be whoever else says average lifetime of the vehicle will be 12,000 hours. The period of ownership, we said we'd use it 2,000 hours per year, so 12,000 hours divided by 2,000 hours per year means we're going to own it for 6 years. The rate of return in this particular case is just 9%, not the 14 you're seeing. So the first thing that we need to do is to figure out what the present worth of the salvage value is, and we say that in 6 years we'll be able to get 12%, 0.12, $155,000. But that's going to occur in 6 years. That's a future cost. We need to take that future cost. We need to take that future cost, and it needs to be moved back. And it needs to be moved back to be the present value, right? So we've got it as our future cost. We want to move it back to the present value. And sorry, I'm trying to write on the screen and it's not cooperating, so that's why it keeps flipping back and forth. So what we need to do is multiply that by the discount factor, which is 1 over 1 plus the interest rate raised to the exponent of the number of periods. In this particular case, it's at year 6, so we use the exponent 6, and that tells us that 12% of $155,000 6 years from now at a 9% interest rate is worth $11,090. The present cost of ownership is also calculated in in a similar way. The first is that we've got the wrong subtraction, so we would subtract off. This is our this here should be the tire value, and our tire value should have been 11,000, and our salvage value should have been 11,000, and I can't remember what the number was, dollars. But you would subtract that from the cost of ownership, which is a present cost, subtract from that the present value of the savings, and it will give you your annual cost of ownership. Annual cost of ownership, this would be the corrected number here, multiplied by the factor that gives us the annualized or a uniform series of payments given a present value and interest rate in a period, and we're getting an hourly cost to own the equipment of $24,152.11. And I'm sorry, this is the yearly cost. We then take that same yearly cost, we say we're going to use it 2,000 hours per year, and the ownership cost is $12.08 an hour. Our operating costs are influenced by several things: the age of the equipment, its state of repair, the conditions under which it's operating, and the type of operating costs we encounter are all dependent on these factors. The first one is maintenance and repair. You need to maintain equipment. If you have a wheeled vehicle, you need to repair and replace the tires. And repair and replace the tires is an interesting one because some people treat it as an operating expense. We're going to treat it as a capital expense. And I have an example later on that shows you how that works. We also have other components that need to be repaired. In particular, parts that will wear out, the blades on a dozer. The engine, the power pack, often has to be overhauled on a regular basis, and we'll see how we address that. And then, of course, there's fuel, and fuel is the ultimate operating cost because if you don't move the vehicle, you need no fuel. And so the fuel is going to be very dependent on its use. Similarly, the environment in which its use is, you're going to run through filters and oil and grease, oil to lubricate the internal portions of the engine, grease to lubricate the external portions of the machine. And trying to scrimp on service or maintenance and repair will always come back to get you in the end. And there's other operating costs. One of them, and we'll talk about how we deal with this in a few minutes, is the downtime. How do we deal with the fact that the vehicle cannot operate every minute of every day for various reasons? You also have the operator, and that's labor, and we'll deal with that separately. And again, the more we use the vehicle, the higher these operating costs are going to be. So, maintenance and repair costs. They are made up of a number of portions. One of those is a maintenance and overhaul. Major maintenance may be replacement of large components. Overhaul may be a rebuilding of the engine or that sort of thing that goes on. We always schedule these overhauls. We don't want the vehicles to break down because we can really get caught in trouble. If you have a shovel that's serving a spread of 20 vehicles that are hauling soil from location 1 to location 2, and the hoe or the shovel or the excavator breaks down, you have a big problem now. Because not only are you not getting any production out of your excavator, you're also getting no production out of 20 trucks. You could easily be spending thousands of dollars an hour without anything to show for it. So you want to schedule that overhaul. Some maintenance will be done in the field. You don't bring the vehicles back to the yard to do an oil change, put new filters, and you have someone come out to do that. And if you're on a construction site, sometimes you'll see Caterpillar's the one that has they're labeled trucks that'll come out and they'll change the oil and they'll do all the filters and seals and everything else that's required on a routine basis. And they'll do that during the times when the vehicle is not in operation. But we'll see that vehicle, those vehicles, those servicemen out there, because it's expensive to float the vehicles off back to a yard to have them maintained and taken back. Tires and components. Tires are wear parts, and they will be replaced during the life of the vehicle. And we'll have a full presentation, a whole lecture on tires because of the importance of maintenance of tires. So if you have a wheeled vehicle, then the value of the tires is subtracted from the purchase price of the whole equipment, because the equipment itself is capitalized over a long period of time, but the tires are never going to last that long. The vehicles are going to last considerably longer than the tires do. And we just do that as a separate cash flow analysis. And it can be affected by maintenance, how well the tires are maintained, how quickly or what the operating speed is, what the haul road conditions are. And then other factors. If you're driving across sharp rocks, usually the tires don't wear out. Usually you get a sidewall puncture that's bad enough that the tire is a write-off. So you need to look at how frequently they need to be repaired. Fuel costs can be calculated based on the load or the requirements we have of the vehicle. We have two types of engines. We talked about spark ignition, gasoline engines, and compression ignition or diesel engines. For a lot of reasons, gasoline is able to give us a much faster acceleration, which is why drag racing cars have gasoline engines and not diesel engines. But if you're going to run something where you need a consistent output of high amounts of flywheel horsepower, then diesel is what you use, which is why diesel is used for things like pumps that run all the time. We're going to need to know what the rate of fuel consumption is. That depends on the duty cycle of the engine. How much are we demanding of the engine? It's the operating conditions. And then, of course, we have the cost of the fuel. And our cost of fuel is something that we can look up. And then we have service costs. There's three components to service. There's filters, air filters, oil filters, gas filters, hydraulic filters, all sorts of things. Oil inside the engine, grease outside the engine. And usually you can determine that as a fraction of an hourly fuel cost, and it is affected by, again, the age of the equipment, the operating conditions, and other factors. Sometimes you just slap on an assumption that you're going to spend $1 an hour or $5 an hour or whatever it is based on your experience on those vehicles. And so we do see a method which we're going to use over and over again, dealing with downtime costs. And the downtime costs are related to those periods when the vehicle is not producing but is still on the site. Now, diesel engines don't like to be started and restarted. It takes a little while to build up the performance and the horsepower. So typically, a vehicle will be running even as it's being filled with diesel, a lot less dangerous than if it's gasoline, because of course diesel won't explode unless it's under compression in the engine. So you will have sometimes when the vehicle is being fueled, or when the operator is getting a sandwich or visiting the Johnny on the spot, or he's going out to look and see what it was that he ran over, or whatever else is going on. The vehicle will not operate all of the time. So we need to know what those downtime costs are. And we're going to use an efficiency factor, not just now. We're going to use efficiency factors for vehicles all the time, and it will be the same efficiency factor. The efficiency factor will be equal to the actual number of minutes per hour that we're actually operating. So if we have a vehicle, a bulldozer, let's say, and it pushes soil forward, and then it backs up, maneuvers to get another lift of soil, and it pushes that same soil forward, that's operating. When it stops so that the operator can go get another cup of coffee, or can argue with the foreman, or can point out to people who've accidentally driven off the highway that they're not really supposed to be there and it's very dangerous. Whatever else, it sits there and it idles. So we'll talk about efficiency and we'll say we have a 45-minute hour or a 50-minute hour, which means that of the 60-minute hour, 50 minutes or 45 minutes is being used for production, and the other remaining time in the hour is being used under just idle time. The vehicles are running, so they're going to burn fuel, and so those are actual hours on the engine that are going to tell us when we're going to get to an overhaul. But some very terrible conditions, you may have 30-minute hours. Some ideal conditions, you could get 55-minute hours. Pretty hard to get 60-minute hours without someone standing there with a whip and a chair. So we should see, takes into consideration, if nothing else, the operator breaks. And then our labor costs. Typically, we would use local data for wage and fringe benefits. And a lot of highway construction depends on the Davis-Bacon Act. The Davis-Bacon Act, or the Prevailing Wage Act, says that in each area, there is a prevailing wage for a particular trade. And operator of a bulldozer, truck driver, operator of an excavator, operator of a crane. These are skilled trades that are identified that the federal government publishes, generally by county, the very largest, and sometimes by city or town in the county, what that prevailing wage is, and you must pay the prevailing wage on all federal contracts. And since a lot of state projects have federal money in them, they count as federal projects as well. And so you need to be aware of that. And I'll show you. We'll look that up and show you how to look that up for various projects. And fringe benefits or fringe benefits in the case as the slide now says, is around 20 to 30% of the wage. So we can put some of this together. We have a contractor purchasing a wheeled loader for $250,000, plans to use it about 2,000 hours per year, and is going to use it for 6 years, realizing a salvage value of $60,000. The loader tires cost $12,000 for a set of 4. They need to be replaced under his operating conditions at 4,000 hours. The diesel fuel costs $3.90 a gallon. And at an attractive rate of 12%, what are the contractor's estimated hourly ownership and operating costs for the loader? So this is a wheeled piece of vehicle or piece of equipment. So this is slightly different than the track version we did a few minutes ago. We treat our equipment without tires and our tires as 2 separate assets. The first is we compute the hourly ownership costs for the tires, which is a sum of the hourly ownership costs, which is based on their original cost, the expected tire life, and salvage value of nothing. And then the operating costs, if there's some additional maintenance and repair that's separate to the tires from everything else. So the first thing that we do when we go to calculate the ownership cost for the equipment is we subtract off the tires, because we're going to treat the tires separately. And so we bought a $250,000 machine, which came with a set of tires. We separate those two, and we bought a $238,000 machine with $12,000 worth of tires. So as a result, we will use these numbers in a different way. So let's take a look at how we're going to handle it. Well, the tires, we are going to have a tire cost of $12,000. We get 4,000 hours out of our tires, so we're going to replace the tires every 2 years. And so what this looks like is that we have tires being purchased not at 0, but also at 2, at 4, and at 6 hours. And each one of these needs to be converted into a present value using that discount factor, which is 1 plus the interest rate raised to the exponent n. So here n would be 0, and it's 2, and it's 4, and n is 6. And just to remind you that any number x raised to the exponent 0 is equal to 1. So we're going to get 12,000 multiplied by 1, and we're going to get 12,000 divided by 1 plus 0.12, so interest rate's 12 squared, and that will convert that to a present value. Same thing here, same thing there, and I will have a recorded, along with this these new slides, I'll also have a recorded example for you in the morning. You won't know it's the morning, but it'll be the morning for me. So we treat the tires just like we treated everything else that was capital. We said we're going to capitalize it over time. Okay. So we're going to do the same thing with anything else we do. If we happen to put a new paint job on, the paint job costs, I don't know, what does a paint job cost? If we have our paint job at $5,000 every 3 years, then we need one at 3 years, and we need one at 6 years. And we have to convert these to present values. The present value here is equal to the future value divided by 1 plus I raised to the exponent n. So this is equal to $5,000 divided by 1.12 raised to the power 3. And that's equal to I'm going to run my calculator. 5,000 divided by 1.12 divided by 1. That's $3,555.72. At 6 years, it's the present value is equal to the future value, again divided by, with the discount factor in here, and this time n is equal to 6. And if we do that, that is $2,530.90 present value. So we add those two up, and that means our present value of 2 paint jobs is $6,086.62. You don't have to repaint them, most people don't, but if you wanted to, you can treat any expense that is involved with the vehicle hardware, with what they call the iron, that will give you the ability to amortize it or to capitalize it over the life of the vehicle. Same thing with the vehicle. Here we have our purchase price was $250,000 minus $12,000 for the tires is a cost of $238,000. You can see that in our cash flow diagram below. 12 years from now, the salvage value, again less tires, is $60,000. Our tires were 12, so we need to include that in there. Here we've got to take the future value of $60,000 to the good, which will be a negative number for us, right? Because it's costs are positive, comes back, and we can calculate that. Similarly, just like we did for the paint job, we schedule maintenance and repairs as the cost of downtime is quite high. And overhauls Minor and major are capital costs. So let's say, according to the manufacturer, he says, yeah, every 3 years of operation, you're going to need to overhaul the engine. That's going to cost $10,000. So that gives us $10,000 at 3 years, and again at 6 years, because we're looking at a 6-year program. Ongoing maintenance, seals and fluids are operating expenses, and let's assume that it costs about $1 an hour of operation, which would be $2,000 per year. We can now draw out all of these costs. So the costs that we have are the vehicle iron purchase, the recovery of 60,000, and a down, an initial cost of $238,000. We have our tires. We buy one at 0, one set at 2, a set at 4, and a set at 6. Surprisingly, you can probably buy tires cheaper because you buy a lot of tires than someone who might be buying the vehicle. So you will put on a set of tires, and so this is $12,000 each time. We then have an overhaul at year 3. We have an overhaul at year 6, and each one of those is $10K. All of these capitalized costs are converted to a single present value. And so there's a little presentation you'll find on here that sums it all up, right? You take a sum on each year of the future value divided by 1 plus the interest rate raised to the exponent n from 0 to n. And the example that I recorded, and you'll see tomorrow, looks much better. And this is how you come up with your costs. Fuel is an operating cost, so we need to be able to calculate our operating costs for fuel. Most of the time, you can get information from the manufacturer that tells you, for this particular piece of equipment, it's going to burn this many gallons, or this rate of fuel in gallons per hour, when you're operating the engine at high demand, at medium demand, or at low demand. And so the table down in the lower right-hand corner is a table you would look up, and you could get from the manufacturer, or you could get from your own company records. And we need to figure out and estimate how frequently we'll be running our vehicle. So in this case, it's a wheeled loader. So we assume that 50% of the time it will be pushing forward to scoop up soil and carry it. 30% of the time it will be lifting the bucket to fill the vehicles that it's charging. And then 20% of the time it'll be driving back to the point of picking up more soil or more cocoa beans, whatever it is we're moving around. And so we estimate that we're going to have 50% at high engine load, 30% at medium engine load, and 20% at a low engine load. We can calculate our fuel consumption by getting the weighted average. So if we look in the table, it says when we're operating at high, we're using 12 gallons an hour, medium 7, low is 3. So our fuel consumption is a weighted average. 50% of the time, 0.5, we're using 12. 30% of the time, 0.3, we're using 7. 20% of the time, 0.2, we're using 3. We add that together, we find that when we're operating, we are burning 8.7 gallons per hour. Our fuel cost, based on a fuel price of $3.90 a gallon for our fuel, and 8.7 gallons per hour means that we spend $33.93 when we're operating. But we have to now take into account our efficiency. We talked about this already. This is the number of working minutes per hour for our efficiency. So in this case, we think we're going to get a 45-minute hour in production. So the way that we calculate our fuel is that for 45 minutes, we're going to be pushing and working at that $33.93 we just calculated. And 15 minutes every hour, we're going to be sitting idling, not doing any work. Maybe we're waiting for the ducks or the turtles or whatever else lives on the site to move away. For whatever reason, we can calculate based on our efficiency by taking the weighted average. We take our efficiency divided by 60, multiply that by the fuel consumption rate or the fuel cost when we are operating. And then the remainder, which is 60 minus 45 or 15, divided by 60, multiplied by 3 gallons an hour, multiplied by $3.90 a gallon, gives me a fuel consumption of $28.37 per hour. Service, you'll be able to look that up. And in this particular case, we're assuming that we're going to be using $1 per hour of lubricants and grease that need to be redone. And if we do all of that, then we can start to put our two costs together. The first cost that we had was equipment ownership. That was $38.12 an hour. Our maintenance and repair fuel service is $33.12 an hour, giving us a total hourly and operating cost of $71.24 an hour. Now, how do we do this? Well, businesses are going to collect a lot of data. They're going to collect the utilization reports. So in other words, how often are you using the vehicles and at what efficiency? And there's a lot of information systems. This is the big change or big advance in equipment, is that they're talking to each other all the time. And we'll go into this in some detail when we talk about individual types of vehicles. But the engine might send the oil pressure and the coolant temperature and the pressure in the cylinders and the life of the grease and the rate at which it's instant on, instant off rate of fuel consumption. And then we have cost data from the accounting department: purchase, repairs, operating charges, fuel oil grease or fuel oil lubricants, whatever wherever you come from. And we may also just use factors that are in the manufacturer's literature. We'll talk about the manufacturer's literature right before we go talk about vehicles. Utilization data is working time, not calendar. And we have our basis of costing. We may charge you a vehicle for an hour, and that would be a very benevolent construction company. A cost to have the piece of equipment on the site for a day, on the week. If you have been in, if you ever used your company for, if you've ever used your personal vehicle for work for another company, they'll pay you a certain amount of mileage, which the IRS says that is the ownership and operating cost of operating a vehicle is 57 cents a mile. They'll also watch fuel consumption. And we can answer a lot of questions by doing utilization data analysis. One is we can figure out what should we be charging in our individual companies. Are we doing the proper amount of maintenance? Are we doing proper project management? In other words, are our project managers hoarding vehicles and burning up costs when they could be releasing them back to the fleet? Or are they doing maintenance enough? And then when we want to dispose of or replace our vehicles, we can watch. And maybe we get a good vehicle and it seems to be doing better than it should be, and we keep on for a little while, and that saves us some money. The ultimate goal is to determine a unit cost so that we can estimate what the cost of construction is going to be for bidding purposes, and then that we can monitor the actual construction to make sure that we are having the production that we want. And so the way that we would do that is we are going to take the earth-moving unit to be a cubic yard. We'll talk a little bit more about that next time as to what that means to be a cubic yard of soil, because it depends whether it's in the bank, loose in the truck, or has been compacted back at the site. In any case, we're going to use cubic yards, and our production unit cost is dollars per cubic yard. And this becomes very relevant in highway applications, because in highway applications, you may be bidding X number of dollars per bank cubic yard of common excavation. And so you just give them that number. And if it turns out that they'll give you an estimate of how much there is. And then if it turns out that their number is close, then that's great. And if there isn't as much, then you may get a price adjustment. But you need to know what that is, and it's pretty straightforward. You take the hourly production rates in cubic yards per hour. You use that. You divide the hourly ownership and operating costs by that production, and that gives you the production in dollars per hour divided by cubic yards per hour. Will give you a result in dollars per cubic yard. So of this equation, we have half of it, right? We can now calculate our ownership and operating costs for a given piece of equipment. What we don't know is what our hourly production rates are. And so we're going to spend the next several weeks looking at different types of equipment and how to estimate off the job what that equipment can do. So sorry about the broken up one earlier that I had posted. You may be able to find out that if you you go back here and compare the two, hopefully I said the same things, and I'll talk to you later. Goodbye.